Hello everybody, I'm back again. So this is my second video today. So today in my first video, I solved this question, case regis element in an array with mini heap of max size k. So it took time complexity and log k. So this is, I think, the most famous solution for this question, but still there is another question which is named quick select. So in this video, I will explain how I can solve this question with quick select. So yeah, and before yeah start the implementation, let me quickly tell you how I can do the use quick select with an example. So in this case, let me tell you how I can do it. So the core idea of this question approach is firstly, I choose the pivot number. Yeah, I choose six as the pivot here. So basically, I choose the last element as the pivot number. I can choose any number, and I will tell you about this more after solving this question. But for now, I will pick the last element as the pivot number. And what I will do from here is I try to move all the numbers which is smaller than pivot to before um, the final position of the pivot number. And I will try to move all the numbers which is same or equal to pivot to the position greater than the pivot number. I mean, the final position of the pivot number. So I will kind of arrange the array in this way. And what happens next is, because I'm looking for the false number, okay, so let me quickly write it down. So it can be something like 2, 3. Oh, yeah, it should be completely random about the this inside of this segment. But let me say, first, yeah, to save my time, I will just keep the order here. So because I don't have any number which is larger than 6, now pivot is here and all the elements are before pivot. And from here, because I'm looking for the fourth largest element, okay, so because I'm looking for the fourth largest element, which is equal to, here, let me do it in one index, no, zero index. And this is exactly 1, 2, 3, 4. 0, 1, 2, 3, 5. Fifth smallest in zero index. So from here, because I'm looking for the fifth element, and actually this is the 2, 3, 4, 5, 6, 7, eighth position. What I'm looking for, the number I'm looking for, is before this pivot. So I will do the same thing recursively in this range again. And this time the pivot will be 5. And I will keep doing it until I finally, fortunately, find that the pivot number position is exactly the one I'm looking for. Yeah. Just in case, I will tell you that if the index I'm looking for is before the pivot index in the given range, I will take a look at the first half. Yeah. So that's how it works. Okay, so that being said, let me quickly tell you more about this kind of partitioning method. The most important thing is I will move numbers which is smaller than the pivot before the final position of the pivot number. So let me show that with this example. So I will keep this as pivot and I will traverse all of these numbers. And I don't, okay, sorry. And I will move two pointers, writer and reader. And what I will do is, if the number, which is smaller than pivot, if I find such a number, I will move it to the first half. So in this case, I will look for number which is smaller than 3. And because now reader is now at 1, which is smaller than 3, so I swap this reader and writer numbers. Actually, which I mean swaps nothing. After that, I remove the increment the writer index and the reader pointer is iterated to the next position, which is 3. And 3 is equal to 3 pivot, so I do nothing. So I remove the reader pointer. Now number 2 is smaller than the pivot, so I swap reader and writer. Then from here, I increment the writer position, and then I go back to the iteration. And now I find 2, which is smaller than pivot 3. So I swap reader and writer numbers. So now it becomes this and this. Then I increment writer position. Then I will go back to the iteration and move reader position. And now it's 5, which is larger than pivot 3. So I do nothing. Okay. So now I can say numbers which is smaller than 3. Oh, sorry. Which are, oh, wait a minute. Because 3 is, wait a minute. So I swapped only in the case when current reader is smaller than the pivot 3. But somehow now 3 is here. Why is it? Let me go back. So from here, 2 is smaller than 3. So I moved 3 and 2. Yep. Then I would write the position. Then I put reader. Oh, sorry, this was sorry, this was wrong. It should be this and this after swapping. Then I increment writer. Then I iterate reader. And then I do nothing because 5 is larger than peak of 3. So in this way, I can say numbers before writer is smaller than current writer position number. And this can be something like 4. This writer position is not necessarily the pivot number. In this case, by chance, it's 3. But anyway, so what I will do is I will swap current writer and pivot. So after swapping, in this case, it's the same, but it becomes like this. So in this way, now numbers before pivot 3 is smaller, and numbers after pivot number 3 is larger or equal. In this way, I can, narrow down the scope row by row, hopefully half by half. And if I can narrow down the scope half on average, it will be the time complexity should be n log n. Oh no, sorry, only n. Because firstly, I have to traverse maybe all the range, and in the second, I have to traverse only half. Then next, it becomes only fourth, and yeah, and after that, it will be 1/8. So in total, it should be n plus n out of 2 plus n out of 4 plus n out of 8, which is almost 2 times n. So time complexity will be O(n). However, in the unfortunate case, I will narrow the scope one by one. So in this case, it should be 1 plus 2 plus n plus blah 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 n. So it should take n squared time. So I can say on average, amortized complexity should be O of n, and the worst time complexity should be n squared. Yeah, there is a technique that I can avoid this worst case. Um, yeah, there is a, or I should say, there is a way to reduce the possibility of hitting the worst case. So I will introduce it later. Okay, that being said, let me start the implementation. So I will I will implement the recursive function quick select. And in the recursive function, let me find the case smallest, not the largest. And also let me do make this case smallest as zero index because it's more simpler to think as an engineer. I will call this. So case smallest should be, in this case, if number of element is say 4, then if I'm looking for first largest, which is the third smallest in zero index. Also, if I'm looking for this element, which is 1, 3, fourth largest, which is zero smallest in zero indexed. So I can say, yeah, I can make this conversion by doing n minus k. Okay. So from here, I will do the quick select. So I mean partitioning. So first I will choose the largest number here. Then reader should start from low and right should be, yeah. So reader shouldn't reach high. So in Python, range is exclusive on the upper bound, so it traverses until high minus one. Then I will increment the right, swap and increment right. Okay, so in this way now, yeah, numbers smaller than pivot is comes the first half, and finally I will, swap right position and pivot position. So that, I mean, pivot number should be in the middle of the array. Good. So from here, which becomes a bit annoying, but now it becomes like this. Writer is the pivot index. So assuming in the zero index, oh wait, okay, I can simply say, sorry, it's not that annoying actually. So if writer index, I mean the pivot index is exactly k small rest index, then I will return this. Otherwise, the I mean pivot index is before the index I'm looking for, which means that I have to traverse the other half. So let me quickly write it. Yeah. So in this case, if k small rest is larger than, let me write it. Okay, so when k small rest index is before right position, I will take a look at the first half. Yeah. And otherwise, I will take a look at the latter half. So I will do it in this way. Okay. Now let me execute my code. Good. Now it's accepted. So let me submit my code. Oh, so what's the problem with this? Ah, sorry. This is not actually swapping. So I have to swap them. I don't know if this matters or not. Oh, it doesn't matter. Okay, so oh, seems like this is kind of edge case. So when nums is only one element, then what happens is here I'm looking for the zero index, zero smallest one, index zero. And here pivot is selected as index zero, which is one, and W is row, which is zero also. Then in line 41, there's no iteration. So in line 45, I do swapping between, oh, sorry, what I'm doing. So pivot is the pivot number. What I have to do is swap it with pivot index and writer index. Okay, good. And what happens is that, yes, time limit exceeded. Okay, because as you can see, there are so many ones, and yep, there are only a few non-one elements, which are negative 5, 4, 3, 2, 1. Okay, so in this case, what's happening is, um, yeah, I cannot narrow down the scope by half. So it narrowing the scope row by row. So it hits the worst case n squared. And because of the constraint, length of the nums can be 10 to the power of 5, which is too much to be n squared solution. So actually there is one kind of way I can avoid this. So here, instead of choosing the last element as a pivot, I will pick the random index from the range and then make it as a swap, I mean pivot number. So in that way, I can reduce the possibility that it hit worst case. Yep, let me try with this. Sorry, and int. Oh, wait a minute. So, sorry, it should be this. And I will run my code. So this is a well-known approach. Yeah, in computer science. But still in this case, it doesn't work. This is because when I do the swapping, I choose the element which is smaller than that element to the first half. So think of the case like this. If I choose one, numbers which is smaller than one come before. Then I swap this and this. Yeah. which is the first number which is larger or equal to the pivot number one. Then the pivot becomes here. Then I will keep searching for this range, which is rather. Then from here, what happens is that I will choose one as the pivot index again, and actually there's no swapping anymore. Then, because right position is still here, I will swap this and pivot index, which is the RAS index. Then I narrow down the scope in this by one, and it continues forever until I exhaust all the element one by one. So to avoid this, what I can do is, so I will do the swapping even if the number is equal to the pivot one. But if I do that all the time, what happens next is right position moves forward so much, and then pivot and the range is narrowed down in this way, just just like opposite way. It doesn't work. It doesn't help. So the approach I can take is I swap the number in 50% probability. So in some case, I move the right position if number is the same as pivot, and in some case I don't. In that way, the right position finishes at the almost middle position. Then I can narrow the scope half by half. So let me implement that. So in line 57, so I use the swap variable, which is Boolean, as a kind of flag. So if number is same as the pivot, I swap in 50% probability. Yeah, in this way. So the time complexity is expected to be n squared. Sorry, O of n. Yeah, with this approach. Okay, let me run my code. No, it doesn't work. Wait a minute. So, sorry. I have to do writer is right plus one after that. Okay. Yep. Now my solution is accepted. So in this way, I showed the way to avoid the worst case. Yeah, time complexity. Okay, so let me quickly wrap up my today's practice. So I solved this question, case largest element in an array. Yeah, again today. And in this video, I use the quick select approach, which takes amortized time complexity O of n, but in the worst case, it takes n squared. So with this quick select approach, the key is that I use the partitioning. Yeah, I choose the pivot number, which is the last element in the nums array. Then I will do the swapping. Yeah, and finally the pivot is um some position in the array, and all the numbers before the pivot is smaller than the pivot number, and all the element after the pivot is larger or equal to the pivot number in my implementation. Then I can narrow down the scope of traverse, and in that way, I can find the k-smallest element in all of n time. Yep, recursively. However, in the worst case, it takes n squared time, and I hit that case in some test case. So I thought of the way to work around that problem. And the first optimization approach I showed you is pick the random number in the array as the pivot number. But it didn't work in this example, in the example of this question. So as the second approach, second optimization, I use the frog swap and do the swapping in 50% probability if the current number is equal to the pivot. I mean, read the number is equal to the pivot number. So in that way, I could avoid the n squared time complexity, and my solution was accepted. Okay, so with this, let me finish my today's coding practice. Thank you so much. Bye.